My name is Kalaivani, Assistant Professor of Chemistry, JJ College of Arts and Science, Pudukkottai. This presentation discussed about alkaloids. Next one, what is the definition of alkaloids? The term alkaloids mean alkali-like is commonly used to designate basic heterocyclic nitrogenous compounds of plant origin that are physiologically active. Simply say, a member of a large group of chemicals that are made by plants and have nitrogen in them. Example, morphine, quinine, nicotine, caffeine, etc. This slide shows distribution and occurrence of alkaloids. Mostly alkaloids distributed in higher plants, rare in lower plants. Lower plants means the plants of relatively simple or primitive characteristics, especially those which are not vascular plant. Next point, families rich in alkaloids. That means it's a presence of alkaloids rich in the Aponaceae, Rubiaceae, Solanaceae and Papaver families. Next, families free from alkaloids are Rosaceae and Libaceae. These two families are absence of alkaloids. And also alkaloids rich in dicot plants than monocots. That means it's more rich in dicot plants only. Distribution in plant. Alkaloids distributed in all parts of the plants. Example, Datura. In cinchona, alkaloid present in barks. It also present in seeds. Example, Nux vomica. In roots, example, aconite. In fruits, black pepper. Leaves, tobacco. Last one, lactose, example, opium. Next one, functions in plants. What are the functions in plants when the presence of alkaloids? They may act as protective against insects and herbivores due to their bitterness and toxicity. Next point, source of nitrogen in case of nitrogen deficiency, which means alkaloid act as a nitrogen source for nitrogen deficiency plants. They sometimes act as growth regulators in certain metabolic system. That means in plant metabolic system, it also acts as a growth regulators. They may be utilized as a source of energy in case of deficiency in carbon dioxide assimilation. Next slide, physical properties. First one, condition. Most alkaloids are crystalline solids. Few alkaloids are amorphous solids. Example, hematine. Some are liquids that are either volatile or non-volatile. Example for volatile liquids is nicotine and quinine. Non-volatile liquid is phyllocorphine and lysosine. Among these three, most alkaloids are crystalline solids. Color. The majority of alkaloids are colorless, but some are colored. Example, colchicine and berberine are yellow in color and canadine is orange in color. Next one, solubility. Both alkaloids bases and the salts are soluble in alcohol. Generally, the bases are soluble in organic solvents and insoluble in water. Salts are usually soluble in water and insoluble or strongly soluble in organic solvents. Next one, taste. Most of the alkaloids are bitter in taste. So they are bitter in taste. Last property, optical activity. Most of the alkaloids are levorotatory, but few are dextrorotatory. Example of dextrorotatory alkaloid is quinine. Some other alkaloids act as inactive, that is optically inactive. Example, papaverine. If it is optically inactive means no chiral carbon present in the papaverine. So optically active means it's a chiral carbon is present in the particular alkaloid. Next one, basic skeleton, that is chemical skeleton, which means the alkaloids having basic nucleus structure. First one, phenyl alkyl amines. For example, epidrine. Epidrine has phenyl alkyl amine nucleus. This belongs to the alkaloid chemical skeleton. Second one, pyridine and piperidine. Example, lobeline and nicotine. These two are having pyridine and piperidine structure respectively. Third one, tropane. Example, itrophine. Fourth one, quinoline. Example, quinine and quinidine. These two has quinoline nucleus. Fifth one, isoquinoline. Example, papaverine and emmetine. Sixth one, phenanthrene. Example, morphine. Seventh one, indole. Example, ergometrine. Eighth one, imidazole. Example, phyllocorphine. And ninth structure is purine. Example, caffeine. 10. These two are not belongs to the alkaloid skeleton, but some other alkaloids are present in these two nucleus. That only we add this structure. 10th one is steroidal and 11th one is terpenoid. Example for steroidal is solanum and veratrum alkaloids. Example for terpenoid is Taxol. Last one, extraction and purification. Here we follow three methods of extraction. Let's we see one by one. First method, that is method 1. The powder is treated with alkalis to liberate the free bases that can then be extracted with water, immiscible organic solvents. Method 2. The powder material is extracted with water or aqueous alcohol containing dilute acid. Alkaloids are extracted as the salts together with a combining soluble impurities. This is the second method. Next one, third method. This is the last method. The powder is extracted with water soluble organic solvents such as methanol or ethanol, which are good solvents for both salts and free bases. Thank you for watching this presentation.